All right, sixth grade, welcome back in. In this video, we're going to be looking at Module 2, Lesson 7 in your Eureka workbook. And this week we've been talking about dividing fractions and the different ways of thinking about dividing fractions. On Monday, we talked about the difference between measurement division and partitive division. And so here I just have a brief example. So just as an example, we have 8 divided by 4. So there's two different ways to think about this. With measurement division, it asks, how many 4s are in 8? Well, think about that. How many 4s are in 8? I bet you are. Most of you probably answer that and tell me that there are 2 4s in 8, right? Most of you know your division, your basic mathematics. Great. Fantastic. Now, the way partitive division is different is just in the way that we think about the question, right? So partitive division asks, 4 of what number gets you 8? So 4 of what number gets you 8? Well, the answer's still the same, right? 4 2s will get you 8. So modeling my example problem up here using measurement division would include taking 8 of something, right, and taking out groups of 4 from it. So how many groups of 4 can I get out of 8 wholes? So I have 1 group, 2 groups of 4. Now if we do this using partitive division, it's asking us 4 of what number gets you 8. So we have 4 groups of something right here represented by these boxes. So 4 groups of something that equals 8. So we know that these groups, you know your math, you know that these groups would have to be 2, right? Because we know that 2 plus 2 plus 2 plus 2 equals 8. So it's just two different ways of thinking about it and modeling. So the way we would model our first example problem down here using measurement division, which is how we were doing it in the previous lesson, lesson 4, was we first had to take the fractions and give them common denominators, which I did right here. Okay, so go back and look at the lesson 4 video if you're confused on how to turn these into equivalent fractions with common denominators, right? So I got common denominators, so I illustrated that I had 1 whole right here, which was broken up into 20 parts, but I only need my dividend, which is 15/20. So we're going to scratch all the rest of this out, but we need to remember that it's only a fraction of a whole that we're dealing with. Right, so using measurement division again, we would take out groups of 8/20 from our dividend. So we start circling groups of 8/20. There's 8/20 right here. Do I have enough to make another 8/20? No, I do not. But what do I have left over? I have 1, 2, 3, 4, 5, 6, 7 15ths of my dividend remaining because my dividend only had 15 parts. So I had 1 whole group, 1 whole, and 7/8 remainder. All right, so what we're going to be doing today, instead of modeling this using measurement division, we're going to model it using partitive interpretation. So let's go back to the example that I used with 8 divided by 4. When I did the partitive division, I started by modeling the number of groups, right? I modeled my divisor first. So here my divisor is 2/5. So the first thing I want to do is make me a little model. Make me another whole model, right? So this is my 1, this is a whole, and we're going to split it up into fifths. 1, 2, 3, 4, and those are all perfectly even, as you can see. So we have 1, 2, 3, 4, 5 parts of 1 whole, so we have 5/5 of a whole, right? And we want to model our divisor, which was 2/5, so we need 2 parts of this right here. And since we come down here and they ask us to shade that part in, why don't we go ahead and do that? We'll shade in 2/5 of a section. Look at that. That's beautiful shading right there. Great. So that represents our divisor. All right, and once we have modeled our divisors, we know that that 2/5 group right there represents a total of 3/4. Okay, so now we know that this section right here highlighted, 2/5 of this whole represents a value of 3/4, right? But now let's go back and let's think about what partitive division is actually asking us. What kind of question is partitive division asking? So in my example up here, the question was 4 of what number gets you 8? So we had the divisor, 4 of what number gets you the dividend 8? And that's the same question we're asking down here. 2/5 our divisor of what number is 3/4? So what we really want to find out now that we know that 2/5 of this whole represents 3/4 value, we want to find the value of the whole, right? So we know that 2/5 equals 3/4. So we can already assume that this other 2/5 is also going to represent, let me just erase that real quick, is going to represent 3/4, right? This section represents 3/4. This section is equal to this section, so it also represents a value of 3/4. So then what about this section right here? What's the value of this last section right here? That's the last part we need to find out. So instead of counting up like this, let's go back actually. So instead of just circling and counting the 2/5 sections, since that's not going to work out evenly, let's go back and let's think about these two sections right here, our original two sections that represented a value of 3/4. So we have two sections that represent 3/4. So what does just one of these sections represent? How can we figure that out? Well, we would need half of 3/4. Well, what's half of 3/4? Well, we can't exactly take half of 3, can we? No, but we can turn 3/4 into an equivalent fraction by multiplying it by a 1 value. So if we multiply 3/4 by 2 over 2, it maintains its value. 3 times 2 is 6, 4 times 2 is 8. So we know that 3/4 is equal to 6/8. All right, so now we have two sections here that represent a total of 6/8. So that would mean one of the sections, each individual section, represents a 3/8 value. 3/8 is half of 3/4, half of 6/8. So each one of these sections is going to represent a value of 3/8. All right, so still the question remains, what is the value of the whole? Well, we have 5 sections that all are a value of 3/8. So we would just add 3/8 plus 3/8. And you'll remember from 5th grade that when you add fractions, if they have common denominators, you can just add the numerators up. So we add up all the numerators, 3 plus 3 plus 3 plus 3, 3 times 5, 15. And we maintain the denominator. The denominator does not change. So that means this whole right here represents a value of 15/8, right? And that's a little bit different than the answer that we got using measurement division, right? Because when we use measurement division, we found one whole group with 7/8 remaining. Well, I bet some of y'all already did the math on this, and you know that these two things are actually equivalent. 15/8 is equal to 11/7. All right, so I want to jump down to example 2. It asks us to model the following using measurement interpretation. And since we talked about measurement interpretation in lesson 4, and I gave you an example of it in the previous example, I just want to move through this one quickly. So We want to model this one using a measurement interpretation. So again, let's come back up just so we can take a look at my example. So measurement interpretation, measurement division asks us how many of the divisor are in the dividend. So here we have 3/5 and 1/4. So we want to know how many fourths, 1/4, are in 3/5. All right, so again, the way we want to model this, we first need to make these dividends equal. So I'm going to multiply this one over here by 4/4, which again is just 1. And this side over here, I'm going to multiply by 5/5, which again is just 1, not changing the value. So we get 3 times 4 is 12, 4 times 5 is 20. That's just to say 3/5 is equal to 12/20. Those are equivalent fractions. 1 times 5 is 5, 4 times 5 is 20. Again, those are just equivalent fractions, right? So now we have common denominators right here, so we can model this a little bit easier. So I'm going to go ahead and make me a little model right here. And we are going to model, in this case, our dividend, which is 12/20, so we need 20s. God, it's always so big. I'll be right back. All right, beautiful. Fraction bar right here, 1 whole equal to 20/20. We have the 1 whole broken into 20 equal parts. You can see them. They're all equal. Fantastic. All right, but we only want to model our dividend again, which is 12/20, right? So we're going to take from 12/20 right here. So there's our dividend. And for the sake of this interpretation, the rest of these aren't part of the problem. All right, so we want to figure out how many 1/4 or 5/20 are inside of 12/20. So we can start circling, right? We have 5/20 right there. That's 1 whole group. We have another 5 right here. So we have 1, 2 whole groups. So you can see we have 2 whole groups of 5/20, and 2 of the 5 we would need to make another whole. So we have 2 wholes, and 2 of the 5 we would need to make another whole 5/20. So our answer here is 2 2/5, or if we made this into an improper fraction, this would be 12/5. So which model was your favorite? Did you prefer the partitive division method, or did you prefer the measurement interpretation? You need to pick one because you're going to be asked to model using one of those methods in the following exercise. But right now, let's take a real quick breath. All right, and let's back up because I'm about to blow your mind. I'm going to show you a cheat code here for dividing fractions. So we're going to take our problem from example 1, 3/4 divided by 2/5, and we are going to use a shorthand method for finding the quotient. Okay, this method is called invert and multiply. And what we are going to do, we have our original problem right here. We are going to take the reciprocal of our divisor, which in this case is 2/5. Now, what is a reciprocal? A reciprocal is the inversion of a number's numerator and denominator. So we're going to invert. We're going to flip around the numerator and the denominator right here. So we're going to take the numerator, put it on bottom. We're going to take the denominator, we're going to put it on top. So we inverted the divisor, and we multiply with the dividend. So you're thinking, Mr. Sheen, there's no way that this is going to get us the same. Well, let's try it out. So we're going to multiply. When we multiply fractions, we multiply numerators times numerators and denominators times denominators. 3 times 5 is 15, and 4 times 2 is 8. Oh my God. Look at that. That's what we got last time. It's the same answer. Wow. Wow, I can't believe it. So again, Invert and multiply. Invert, you invert divisor, and I spelled this correctly and with great handwriting. Invert divisor and multiply. And multiply, right? So let's go back and let's take example 2 and let's just prove this out. Let's just check that that wasn't a fluke, right? So in this other problem we have 3/5 divided by 1/4, so let's do that right here. 3/5 divided by 1/4. So again, we're going to invert the divisor. So we're going to take the divisor 1/4, invert it, put it 4/1. And instead of dividing, we're going to multiply times 3/5. 3 times 4 is 12. 5 times 1 is 5. Let's check. Let's make sure that we got the right answer. So when we invert and multiply, we get an answer of 12/5. But let's just come down and check and make sure that we got the right answer. Oh, look at that. It happens to be 12/5. So we've checked it. We made sure that that was not just a fluke, right? So, and this is pretty much how I would ever want to divide fractions. But like I said, in example 3, which is what I'm about to send you on right now, is going to ask you to, oh no, it doesn't. Not number 3, but, oh, well, I still want you to, in example 3, I want you to use one of those models. Okay, you can either use the measurement division or partitive division models. You choose, and I want you to not only answer, you can use the invert and multiply to get a quotient for this, but you still have to draw me a model, okay? So I'm going to give you about 4 or 5 minutes to work on that. Go. All right, great work. Thank y'all for being so productive. Okay, so I'm first going to find my own quotient here just because I like the invert and multiply. It saves me a little bit of time, a little bit of thought. So I'm going to invert my divisor. 4/3 times 2/3. 8. Nice. Should be my answer. Now, I'm going to model this guy. And I actually prefer the partitive method, so I'm going to take a quick break right here, and I'm going to draw out my partitive example. All right, now that I've shown you that little cheat code right there, I want you to use the invert and multiply method right here. Invert and multiply on example 3, okay? I'm going to give you approximately 90 seconds to do this. Shouldn't need that much time. Go ahead and go. All right, so thank you for your attention. I want y'all to go ahead and move forward to the exit tickets. Take a note of the lesson summary right there. We talked about that. That's the invert and multiply rule. And the problem said they're going to ask you to invert and multiply with all of these. Now, let's go ahead and talk about an example like this one, example B. So here we're dividing fractions again, but our divisor is not a fraction though. But let's go back to lesson 4 and let's remember the rule that any number can be represented by a fraction, right? How would we represent 4 as a fraction? Y'all tell me, how would we represent a 4 as a fraction? Well, couldn't we just put it as 4/1? Perfect. 4/1 is equal to 4, and that will work for any of these whole numbers, right? So if there isn't another whole number in here, but anytime you put a whole number under 1, you make it a fraction, and then from there you can use the invert and multiply rule to divide, right? So keeping it moving, none of those things. Okay, remember your rubric for answering constructor response questions. Fantastic. You see, in 6 and 7, you're going to be asked to draw a model, so you're going to either have to pick the measurement or partitive models. Fantastic. Okay. Thank y'all so much. I'll see y'all in the next lesson. Bye.